Thank you. My name is Anders Jansson. I'm the commercial director at CorPower. And at CorPower, we are working very hard to commercialize wave energy. And we see that wave energy is a key technology to enabling 100% renewables in the future. And the reason for that is when we start looking at the grid, we see that we have a number of intermittent renewable sources, such as solar, which is the yellow one, and then we have the wind, which is the blue one, and that creates gap onto the grid. But if we add wave to it, we get a much more consistent energy input to the grid, which is of high value. So this is 1 week in California, and when it becomes really interesting is when we look at it from a yearly perspective, because then we see that the wind and solar peaks during the summer months, whereas the wave energy peaks during the winter months. And so we get a natural time shift between wave, solar, and wind. So we can decrease the amount of storage, such as batteries, and add another renewable energy source into the grid. So we think this is really why we keep pushing for wave energy. And as you've probably seen, floating wind has boomed the last couple of years. And we start looking at the areas where you want to install floating wind. We see that they correlate very well with waves. So this is a real opportunity that we and a number of our customers have really identified, because you can have this natural time shift between the wind and waves. And you can get a much higher capacity factor with reduced output variability, which means that your electricity becomes more valuable to the market. And you can also decrease a number of the CapEx cost and product development cost, so you can lower your total LCOE onto the market. So why hasn't it happened before? Because the ocean is a fierce environment and is a real challenge. And that is, firstly, to survive the biggest storms, and you maximize your revenue to cost. So the way we have looked at it is to minimize your peak loads, because then you can have a more cost-effective power plant, and maximize your average annual load. And we've been fortunate to base this on about 50 years of research in waves. So Professor Falnes is one of the sort of gurus within wave energy, and his protege, Jürgen Hals, invented something called inherent phase control technology. And this has really been the step change why we believe CorPower has now cracked the code for wave energy. So to give you an idea is that we become transparent in storms because we work out of phase. So we are pretty much pitching a wind blade into wave energy. And then we are amplifying the device in normal operation. So we can move up to 10 times faster than any incoming wave. And for that reason, we can produce significantly more electricity than seen before. So to put some metrics into this, oh, sorry, you can't really see that. We have proven that we produce 3 times more energy per PTO force than ever seen in wave before, and more than 5 times energy per ton. So that's the cost. And that means that we are now matching the structural efficiency of a modern wind turbine. And that is for our first commercial scale device. So we think, or we're convinced that we can improve that over time. So far we've proven in the ocean in 2018 that we are transparent in storms. We have been able to prove that we produce more than 300% more annual energy than ever seen in wave before, and more than 500% energy per ton. And for that reason, we see a clear path down to 40, even below 40 euros per megawatt hour going forward. We are following a very structured product verification roadmap, and we think this is key because there's so many challenges when you do waves. So we started off very small, and then we did a half scale in 2016 to 18, and now we are in the first full scale, which we will install next year. And then we're going into a small pilot, and then we are ready for pre-commercial arrays. So really, the key sort of short-term target is to be ready for commercial arrays from 2024. And in order to get that, we need to become bankable. So we're going through a very, I would say, hefty certification process, and we have done that for the last 4 years with the DNV. And I think this is where, after this, where we see an exit potential from most likely one of the big investors in floating wind, such as Equinor, Mitsubishi, Shell, etc. So our process, our methodologies, and what we proved has gained us a lot of traction between customers, I would say. So we have about 500 megawatts in project pipeline. And we have now customers investing in project development in the UK and Ireland. Our business model is that we are an OEM. We want to be selling 10 megawatts of clusters of wave devices and then work with EPCs and towards customers. So to summarize, we have proved that we have the world's most effective wave energy converter. We have the physics to support the LCOE, and we see ourselves as a key enabler to 100% renewables. And most importantly, we have a really dedicated team. I think we consist of 13 nationalities. We've been able to handpick people from all over the world. Thank you.
Right, thank you. We've run a bit over there, so I've got to deduct you a couple of questions, I'm afraid. So let's take a couple of questions from, yes, sir, over there.
Hi, you mentioned getting to 40 euros per megawatt hour, which is quite impressive compared to wave energy's past performance. It's fair to say people like Carnegie and Pelamis. What would be the one main reason or two reasons why you think you can get to that very low number?
So we are a very lightweight concept. So we weigh less than 200 tons per megawatt. So if you compare that with example, Pelamis, I think they were down to about 1,500 tons per megawatt. And we're not using any specific materials. So that's one thing. The second thing is that we accelerate the velocity of the device in normal operations. So we get a speed of 10 times the actual incoming wave. So for that reason, we can produce much more electricity per device as well.
And I'll take one down here.
Thank you. Just two questions. Maybe you could tell us more about the team and the shareholders, and also in terms of the mechanics, the grid connection, I guess. I guess that's a challenge, and I was wondering, your solution seems to be in developed countries, mostly European countries. Is this something that you can scale up to developing countries where grid connection might be a bit more challenging, or not really?
So team, we have attracted about 28 million euros in investment. Our biggest shareholders are Midrock New Technology, which is a big engineering company owned by a Saudi Arabian sheikh. They also invested in Tidal, so they're quite involved. And then we got Almi Green Fund, which is a state-owned Swedish green fund. And then we got a number of angels. And the team, so Patrick, CEO, who co-founded the company with an inventor, is a serial entrepreneur, was in semiconductor before. Myself, been in Tidal for about 10 years. We did an IPO with that company. It's still going strong, called Minesto. And the engineering team has come from, I would say, mainly other developers within the marine, wave and tidal sector. So we got good competence there. And I think most importantly, we also now build a good team within sourcing. So our supply chain is key. So we are obviously the design team, and then we need large manufacturers such as ABB and so on, helping us to make sure that we get real good products out on the market.
Okay, and so I know you had a quick one you wanted to lob in.
Yeah, thank you for the presentation. We like it. My question is about maintenance. What are your projections on the maintenance of these fields?
So the maintenance strategy is that we actually do a swap, because the device is fairly small. It weighs about 70 tons, 65, 70 tons. And for that reason, when you have maybe 100 devices out, you go out and do the swap. Whereas some of the components you can switch out on the sea, so you can actually lock the device. So it doesn't move. So that are more, electronics that that we have added in components that you can get to out on the site. But the real big service maintenance is done on land.